Good morning, good afternoon. Welcome everybody to this fifth webinar of our operation and maintenance series. Thank you very much for joining. It's great to have you here. We'll be starting the webinar in just a few minutes' time as we wait for everybody to join. While we're waiting, we're going to have a short poll which will appear on your screen in front of you, and if you'd be kind enough to fill that in, we'll have the results of that up in a couple of minutes' time. So while you're waiting to start, please fill in the poll on the screen in front of you. The first question there: what level of familiarity do you have with O&M of wash infrastructure? And the second question, do you have any experience of working with groundwater supplies? As we'll be talking about groundwater today. So if you're just joining us, welcome. Good morning, good afternoon, wherever it is you're calling from in the world. Welcome. This is the first of our fall series or spring series, if you're calling in from the Southern Hemisphere, of webinars, the ProWash webinars on operation and maintenance of water, sanitation and hygiene infrastructure. If you wouldn't mind, please filling in the poll in front of you. We'll be getting started in just a few minutes' time. And we'd also very much appreciate it if you would introduce yourself in the chat box. You'll see the chat box at the bottom of your screen labeled chat. Please put your name and where you're calling in from. It's great to see who everybody is and where you're calling in from. So please, while you're waiting, introduce yourself in the chat box and fill in the poll, which should be on the screen in front of you. Poll questions: what level of familiarity do you have with O&M of wash infrastructure? And the second question, asking about your experience of working on groundwater supplies. What level of experience do you have working on groundwater supplies, if any? And we'll have those results up in a minute. It's really interesting and useful to have some of that information. As I say, if you're just joining us, please also fill in your name, if you wouldn't mind, your name and where you're calling from in the chat box at the bottom of your screen. Welcome everybody. Welcome if you've just connected to this webinar on operation and maintenance of wash infrastructure. The poll in front of you, please, while we're waiting to start, complete that poll. 2 poll questions there, and please introduce yourself in the chat box if you haven't done so already. Thank you for that. And I think we'll be done with the poll in just a second or two, and we'll be seeing some of those results. Right, I think. Fantastic. Thank you very much, everybody, for joining us. Thank you for filling in the poll, and thank you for introducing yourself in the chat box. So that I'll just quickly go over the poll results to you. This is interesting. What level of familiarity do you have with operation and maintenance, water, sanitation and hygiene or wash infrastructure? Round about a quarter of people saying that they don't work on O&M at the moment but are interested in it. About a third of folks are occasionally work on O&M and understand the issues. About another third work on O&M quite often and are familiar with it. And 11% are saying this is a major part of my work and I'm very familiar with it. So it's a real mixture, and if you have any interest at all in O&M of wash infrastructure, you've come to the right place today. Welcome. The second poll there: do you have any experience working with groundwater supplies? Well, we have roughly a quarter of people, or more like a fifth of people, saying they don't have any experience at all on groundwater supplies. 44% have a little experience. About another third say they have work a lot with groundwater supplies, and 3% of people, a small number, say they are a groundwater professional. So again, it's great to have you here if you're have any level of experience at all in groundwater or groundwater supplies, welcome, you've come to the right place. We'll be getting going just in a second or two while we wait for everybody to join. Please, if you haven't done so already, introduce yourself in the chat box at the bottom of your screen, and let us know who you are and where you're phoning from in the world, or where you're calling in from. We have a whole range of folks, so good morning, good afternoon, good evening even, whatever time it is today, and welcome. Thank you very much for joining us. I'd like to extend a special welcome to those French speakers who are tuning in today. We'd like everybody to be aware that we'll be providing French interpretation for this event. If you'd like to follow the event in French, please click on the small globe at the bottom of your Zoom screen and where it says interpretation, and select French. Once you've selected French, you can choose to mute the original volume, or you can hear it in the background at a lower volume. But we'll be having French interpretation, so please do select that. And we'll be putting a copy of the presentation in PDF format into the chat box so that you'll be able to follow that in French as well. If you have any technical issues during the webinar, please send a chat message to my colleague Suzanne Prowash, and we'll do our best to assist you. You'll see in the chat box that there's a little pull down arrow there, and if you select Suzanne, she's our technical specialist today, and she'll be able to assist you with that. My name is Jude Cobbing, and I'm a senior specialist for water infrastructure and governance for ProWash. And for those of you who are unfamiliar with ProWash, we're an initiative funded by USAID's Bureau for Humanitarian Assistance, BHA, and led by Save the Children. ProWash aims to provide support to implementing partners in order to strengthen the quality of WASH interventions through capacity strengthening, knowledge sharing, and applied WASH research opportunities. And anyone who's interested in learning more about ProWash, please visit our website on the FSN network, and by clicking on the link in the chat box, and there's some more information about ProWash on that. As I say, please introduce yourselves in the chat box if you haven't done so already. We like to know who you are and where you're coming from. Just a little bit of housekeeping as well, first of all. After the webinar, we'll have the speaker in a minute, and once the presentation is finished, please post your questions in the Q&A box. The question should be in a Q&A box at the bottom of your Zoom screen, not in the chat box. And please feel free to post questions in that Q&A box anytime during Alan's presentation or afterwards, and I'll get to your questions and we'll make sure that they're addressed to the speaker after the presentation. Please don't worry if we don't get to any of your questions. Rest assured, we will answer them. Any questions that aren't answered in this webinar, we'll be sending a full list of them to the speaker, and we'll be circulating a full list of answered questions at the end of the webinar. So please don't worry if your questions don't get answered. Equally, please feel free to put them in the Q&A box at the bottom of your Zoom screen at any time. And you can also upvote questions in the Q&A box, by the way, that you'd like us to answer. So please engage with the Q&A box at any time during the webinar. So welcome those who've just joined us. Please introduce yourselves in the chat box. Remember to click on the interpretation button to select French if you'd like to hear the French interpretation. And please remember to ask all questions in the Q&A box at the bottom of your Zoom screen. So to moving on now today, it gives me real pleasure today to introduce Professor Alan MacDonald of the British Geological Survey. Alan and I were colleagues some years ago, and it's great to work with Alan again. Alan's a principal scientist with the British Geological Survey based in Edinburgh, Scotland. And Alan has extensive experience with groundwater supplies in Africa and elsewhere. And his interests include sustainable water supplies from hydrogeologically complex environments, groundwater quality, and water supply sustainability. Alan was a lead researcher on the UpGRO project, and he has collaborated extensively with partners in Africa to improve water supply security. Alan, over to you.
Thanks, Jude, for a lovely introduction, and it's great to be here. Thank you for inviting me to be here amongst you. Jude and I worked together in Nigeria with UNICEF colleagues, so lots of happy memories of weeks spent there together up in Jos. So today I'm going to speak to you about an UpGRO project that I was leading for 5 years, looking at borehole functionality, and it was called A Hidden Crisis. The funders never really liked that name. They said it was too negative, so we had to have a strap line that said understanding failures for future success. So this was part of the UpGRO program, which there was 5 large projects, of which I was doing one of them, and then about 15 smaller projects, and then there was also the Groundwater Atlas for Africa. So if you want to learn more about UpGRO, just type it into Google and you can see all the different projects that were funded. Next slide, please. So the project I was leading, the Hidden Crisis, ran from 2015 to 2020. And we had a large consortia working together with WaterAid and a lot of researchers in Malawi, Ethiopia and Uganda with the universities there, but also with universities in Australia and with ODI, Overseas Development Institute. So there's 5 parts to this program. First was to try and define functionality, then to apply this new definition to carry out surveys in Uganda, Ethiopia, and Malawi, then to dig in much deeper and do some detailed interdisciplinary studies of some failing water points. We also then, alongside this, had some longitudinal studies to really dig in deep in terms of community experience of what functionality meant to them. And then finally, we had a dissemination and a lot of work with the local ministries for water to try and make sure that some of our results were operationalized. Next slide, please. So the first part of this then, I'm going to talk you through most of the project, but the first part of this, we thought it'd be quite easy. What's a functional water point? And it starts off being easy. And then once you think about it for more than about 10 seconds, you realize, actually, it's not that simple. What do we mean by functional water point? Well, of course, just that it's working. Well, what does working mean? So digging into that was quite difficult and very interesting. And we came up with kind of 4 things that we thought were quite important for when you are measuring functionality. One was that it's actually measured against a stated standard. So functioning, how much water is coming out? Is it the design yield of that borehole? What is the actual standard you're measuring functionality against? And secondly, the population of water points. Is it all the water points have ever been constructed in the last 2,000 years in a country, or is it functionality of a project for the last 5 years? What's that population? We also, for our study, wanted to do it separately from users' experience. Now, users' experience of the water point is really, really important, but we wanted to measure something slightly different. Was the actual water point doing what it was meant to do? Users might not think there's enough water because they need another 5 water points, but we wanted just to measure what is it that the water point's doing? Is it doing what it should do? We also thought it was quite important that assessments should be tiered. And by that, I mean, you can go from a simple, yes, it's working, no, it's not working, into something more complex, to dig in a little bit to work out what isn't working about that borehole. So having the ability to tier these assessments. And finally, to be able to distinguish between a snapshot of a certain time and also looking back temporarily. Has a single water point been having problems with breakdowns over the last few years? So to measure these 2 different things. Next slide, please. So we then came up with this flow diagram that just kind of explains a little bit what I was doing there. This flow diagram gives our short project definition. The top left is our basic definition. is water flowing or not? You can click on the button there. That gives us our basic definition. And then next, we have, is it giving you the amount of water that you're requiring? Is there sufficient quantity? So that, is it giving the amount of water that's required for that borehole? And then finally, we added in that temporal definition. How long has it been working for? Or how long has it not been working for? Has it been down for more than a month, a year, for example? And that gave us these 6 definitions, from fully functional, partially, to low yield, and finally to abandoned. And these are the definitions we used in our project. If we can go on to the next slide, please, Suzanne. So we then took this new definition and we applied it to 600 sites in Ethiopia, Uganda, and Malawi. And we used a lot of statistical help to give ourselves a good randomized sampling methodology, which meant we didn't have to sample every water point in each of these countries, but we measured quite a small sample that we believed was representative of the whole country by doing a lot of interesting statistics and randomizing, making sure we had a randomized approach to our sampling. And then the tests we used took about an hour. We had some physical tests, such as doing different borehole tests. And then we also did some chemical tests because we were interested in the water quality as well. And then we had some questions, 20 questions that we used to quickly assess the governance arrangements of that water point, to try and investigate the functionality of the water point committee as well as of the water point. So this is a methodology that we applied to these 3 countries. And as you can imagine, it took quite a lot of surveying. So we were in the field for, I think in total for this 18 months across the 3 countries, carrying out these surveys. Next slide, please, Suzanne. And here are our results. I'm going to give you the results for Ethiopia. So first of all, the result here is of our basic functionality. So that definition which says, yes, there is water coming out of this water point. It is functioning. There's some water coming out of the water point, versus no, there's no water coming out of this water point. It's not functioning. And we got this result of 82%, which was really interesting and a relief to us, because that was almost exactly the same as what the Ethiopian government had got from its national survey of water points. So this kind of yes-no functionality measurement was very similar to what the large survey of what the Ethiopian government did. And the next definition was adding in reliability. Sorry, not reliability, it was adding in yield. So this was, is a water point producing the amount of water it's meant to be, which I think was about 10 litres a minute. Is that the amount of water it's meant to be producing for people? And we found then that our functionality reduced to less than 60%. So although there was water coming out of these water points, for a lot of them, there wasn't the amount of water coming out that you would expect this borehole and hand pump to produce. And thirdly, we added in then reliability. So was this water point working for more than 11 months a year? And Suzanne will put up the results now. And here for Ethiopia, we found out that then dropped to 45%. So 45% of the water points were working most of the year and giving the yield that they should, but more than half of them weren't. So more than half of them were not providing the water service that you would expect. And then finally, we added in a water quality survey looking at TTC, so tolerant coliforms, and inorganic chemistry, so fluoride and arsenic and things like that. And when we add that in, then we get to about 28% of them were actually giving not just the amount of water reliably throughout the year, but of the right quality. So we found this tiered approach really useful and interesting for digging in behind some of the functionality numbers that we hear. So we hear 80%, we hear somewhere between 60 and 90% water points functional, but if you dig in behind that and see what service level are they providing, then our kind of methodology here gives you a more nuanced and interesting story of what the service level is that these water points are producing. So next slide, please. So along with that, we looked at the management arrangements. So is the water point committee or the governance arrangements for that water point, how are they functioning? And we looked at the finance system, if maintenance and repair was affordable and available, looked at decision making within the committee, looked at external support. And we came up with some results, if you put them up, Suzanne, which show that I think this was this is across all our 3 countries. They showed that our water point committees, our governance arrangements were not too bad. They weren't too bad. They were actually seemed to have a lot of the right things going on. And very interesting, we found that there was hardly any relationship between how well a water management committee was working and how the water borehole was functioning. So there wasn't a very straightforward, easy relationship between the two of these. And this shows the complexity behind what's required to keep a water point functioning. Even with a very well-managed committee, the water point still could have lots of problems. And the only thing that we found a slight relationship with was the maintenance and repair. If the maintenance repair was easily available and affordable, then that could predict a little bit the functional of the water point, but other things not so much. So interesting results, food for thought. Certainly not saying ditch water management arrangements committees, because they need to be managed in some way. But I think it's interesting to look at some of the assumptions we make about the strength and quality of a committee and the function of a water point. So food for thought. Next slide, please. So then moving into the next part of our project, we went to 150 water points across the 3 countries that were not functioning very well. So we looked at ones that weren't functioning too well, and we began to forensically take them apart. We spent 2 days in each community, each water point, and we took it apart to try and investigate what were the reasons behind poor functionality. So next slide, please. So first of all, we deconstructed the pump, and they've got a picture there of our team doing that in Ethiopia. And of course, we had to be very careful to make sure that the community was very much on board with this. So WaterAid were fantastic partners and worked tirelessly to make sure that everybody knew what was happening, and that we always left the water point in a better condition than we found it. And you can see in the background there's some water tanks. We made sure that there was water available for everybody to collect during the time that we were doing this work. So we deconstruct the pump. We'd look at the material of the pump, the construction. We'd look at evidence of corrosion of the rising mains. We looked at the thickness of the plastic risers in AfriDev pumps. We looked at galvanizing, how much galvanizing was present. So we did a lot of work, forensic analysis on the actual pump itself. Next slide. We also looked at the aquifer properties, and I'm a hydrogeologist, so I love pumping tests. I like anything to do with aquifers. So this was a great joy for me, for us to do 150 pumping tests. And here what we did was we pumped the borehole for 5 hours, measured the drawdown within that borehole, and then you can measure the transmissivity, which is the currency that hydrogeologists work in. That tells us how good the aquifer is, how much water you might be able to withdraw from it. So we looked at the transmissivity, but also the water levels. How deep are the water levels in the borehole? Because that's one of the issues with hand pumps, is it's very difficult to work out the water level in a hand pump. And some of you here may be involved in some of the sensor work that's trying to get more data on that. So that was pumping tests for aquifer properties. Next slide, please. And then we also looked at water chemistry, and what we were doing here was looking at both water quality and residence times of the water. So for water quality, we were trying to work out how many were contaminated, and we looked at total thermal coliforms and found that maybe across the 3 countries, about 20% of the sites failed on coliforms. There were slight differences between the 3 countries, but actually that meant that over 3/4 of the water points, actually the coliforms were low or absent in, so that it was providing good quality water. So we found from this work, which was carried out in the dry season, is that contamination was not a massive issue from coliforms from these boreholes. And I know that there's other work out there that suggests some are more contaminated than others, and we've published quite a few papers on this to try and show what's going on here. And then for inorganic chemistry, about 10% of the sites failed on inorganic chemistry. And then finally, we looked at the residence times. Now, this was trying to work out something about the groundwater age and how coupled it is to rainfall and recharge. And this graph looks at 2 dissolved gases. And if you've got these dissolved gases in the water, it means it's been recharged sometime in the last 50 years. And points up to the right means it's more modern. Next slide, please. Then we used a borehole camera to look at the borehole construction. And this was useful to check the depth of the borehole, to look at the position of the screen, to see how it had been constructed, and to look at any problems with joints or splitting of joints. Next slide. And alongside this, we had a team of social scientists out for exactly the same time as the physical team, so they went out together to make sure it was an interdisciplinary study. And as the physical work was going on in the background, the social science team developed some focus group discussions to look at various aspects. One was to look at the breakdown history. How often had it broken down? What happened when a borehole broke down? Who managed it? Who tried to repair it? Where did the money come from? How was that organized? We also looked at the impacts of the breakdown. So when it was broken down, what did people do for water? Where did they go? How did it impact some of the marginalized groups within a community? And then alongside that, for about 12 communities, we did longitudinal work, and looking at community diaries with local village researchers, community researchers, keeping diaries about what happened. And this was managed by Francis Cleaver and Luke Whaley and Ivan Smithanga at Malawi. So there are a lot of really interesting social science research on what people did when boreholes failed. Next slide, please. So now just as I come to the end of my presentation, really, it's really to give you some of the results, and then we can open it up for discussion. So the results, first of all, of the physical studies. I've got 5 different results here. The first one is about recharge, and that's something that us hydrogeologists spend a lot of time worrying about. Is it sustainable? Are groundwater supplies being recharged by rainfall, or is water going to run out? And what impact does climate change have on that? So what we found from this work and other work is that for rural water supplies, which don't take a lot of water, then most of them are actively being recharged and recovering. So we did a separate study in Ethiopia looking at the El Nino drought, and Donald John McAllister and Sefa Kebede were working on that. And there we found that during the prolonged El Nino drought in the Ethiopian highlands, groundwater supplies were quite resilient, and then afterwards were recharged and recovering. So rural water supplies are actively recharged and recovering. So that's good news for us all. Now, if you start taking out 10 times more water, then we're in a different scenario. But for rural water supplies and the amount of water that's taken then, it's not a major issue. The second result was that corrosion was ubiquitous. Wherever there was India Mark II pumps, where there was mild galvanized steel, we found corrosion. And that's partly just to do with the chemistry. When you put galvanized iron in water, it will start to corrode. So I put two pictures up there showing some of the impacts there of a hole in the rising main, and also for the connectors for the pump. So corrosion was ubiquitous. Thirdly, we found that aquifer properties, so how permeable the rock is, had a strong control and functionality. And that graph we've just put up there shows the 3 different countries and shows the transmissivity. High transmissivity is good. It means the water flows quickly through the rocks. Low transmissivity means it's more difficult. And you could find across the functionality categories, particularly in Uganda and Ethiopia, you'd find that more of the functional water points were occurring where the transmissivity was high. So therefore, the geology does matter. It matters where you site these boreholes, that it's in permeable rocks that can allow the water to flow to the borehole. Fourthly, we found that the rising main was not really what the standard suggests. When you look at the lovely standards that are put up by RWSN from the old standards for different types of pumps, we found that the rising main here was not what it was meant to be. The line there shows the thickness that it's meant to be according to the standards. Most of the rising main was thinner than that. Whether that was due to corrosion or whether that was because it was thinner to start off with, we haven't got to the bottom of, but there's other projects now looking at that. So widespread substandard rising main. And finally, that water levels in some places were really deep. So here's the water levels. I think these ones are for Ethiopia. And when the water levels below, about 20 meters, you can have problems with a hand pump. A hand pump really struggles below 40 meters. It's almost impossible to use a hand pump without modifying it to be there's some modified deep hand pumps. But these deep water levels, we're having issues with water points. And some of the reasons to do that were to do with competition from other users. So particularly here in Ethiopia, there was flower farms and other agricultural activity taking out a lot of water, and that was causing issues for our hand pumps close by. So water levels were deep, and this was surprising to me because I've spent a lot of time saying, water levels generally in populated Africa are shallow enough for a hand pump, but here we found actually in some places they were deeper. So a surprise to me. Next slide, please. And then for the social science results, and I'm just going to go very quickly through these. We found some really interesting results. And again, Luke Whaley, who led a lot of this analysis, has written a number of papers on this with Francis, and also WaterAid have been very much involved with these discussions as well, with some of our results. Well, first one is about going with the grain. And by that, we mean going with what's already there. What we found was that management that tended to work was management that was using existing structures rather than building a different structure. So it might be a church group, it might have been an agricultural group that was there, a women's group, different structures that were already there that were already entrenched in the community tended to work well. That's what people would fall back on to get their water point working again. But behind that then are other questions. Well, what about existing inequalities? Does using existing structures entrench some of these inequalities? So something to think about. The second issue here was really about some of the challenges of district support. we found that water points really needed external support to be working well. So either somebody from the private sector to fix it, or somebody from the district. But across the piece, we found districts so poorly supported that the demands upon them were much greater than they could meet. So the will might be there, but there was really little ability to do a lot of fixing, particularly if it was replacing rising mains or something like that cost more money. So a real challenge of district support, because water points do need support. It's, you know, most communities are not able on their own to fix things like rising mains needing replaced. A third point was really about the worldviews and how people's worldviews really shape the local water management arrangements. And for us as WASH professionals, really thinking about how different situations require different solutions. If we find something works really well in one place in Kenya or Uganda, then picking that up and putting it somewhere else where people have different worldviews might not be successful. So just the importance of people's worldviews on how management arrangements work. And finally, really the huge pressure that we found on local water points. This was through the community diaries. There was massive pressure on individual water points throughout the year. So there was always something going on, be it a funeral, be it a wedding. There was always a high demand on these water points, and communities under a lot of water stress and having to negotiate sharing water points and internal conflicts as well. Next slide, please. So that's me finished, and really leaving you with a few thoughts to ponder. First, really, well, first to show that the project team on the bottom there was about 40 different researchers involved in this work across the 3 countries and in the UK and Australia, and a tireless amount of work. We think there was about 20 person years of field work involved in this project. So a lot of people spend a lot of time in the field to get these data. So first of all, definitions really matter. We got from 82% to 22%, I think, in Uganda, from using different definitions of whether a water point was functional or not. So definitions really matter. Secondly, people manage water in really different ways. And thinking about using existing structures, this idea of going with the grain, seeing what's already there and seeing what people's worldviews are so important. But then lots of interesting questions about how that's actually operationalized. Thirdly, that poor functionality and high demand have really real and frequent impacts on communities, and particularly the more marginalized. So water points being not working for a couple of months have caused real issues and real problems, particularly for the marginalized. Now, the reasons for failure are really complex. It's a multitude of things to do with poor aquifers, where water points are sited, some deep water tables, quality of material, and maybe the construction. And maybe the takeaway message from that is that regular maintenance is required, very much required. Rising mains will fail and will need replaced. So we need to build that into our programs, knowing that they do need to be maintained and replaced. Fifthly, the important role of district and national government, and just in setting standards and supporting communities. And I know a lot of people on this call are involved in this sort of work as well. Just how important it is to be able to support these external agencies to the community to help operate and maintain these water points. And then finally, just looking forward, there's a lot of interest in higher yielding groundwater supplies for solar power for reticulated supply. And I've been involved in quite a bit of work like that myself. I don't think we should underestimate the challenge of that. The issues that we can have with community water supply will not go away when we move up the scale towards reticulated supply. So higher yielding groundwater supplies might be a challenge, particularly if the aquifers aren't permeable enough to support it. So looking forward, we shouldn't underestimate the challenge of having higher yielding particulated supplies. Okay, thank you very much. That's me finished, my presentation.
Thank you very much, Alan. That was really interesting. Really, really appreciate that presentation. Absolutely fascinating to hear more about the UpGRO work. And, you know, to me, one of the most interesting things about UpGRO is just the huge range of investigative techniques and subjects that you've used to analyze sustainability or performance of rural groundwater supply. So, you know, absolutely fascinating. And we've put the UpGRO link into the chat box. So please, anybody who's interested, have a look at that link, have a look on the UpGRO site. There's a video there, there's resources, there's links to some of the publications that Alan mentioned in this. Alan, I have a whole bunch of questions myself, but we can probably save those for another time. We would like to encourage anybody who has questions for Alan, please put them into the Q&A box at the bottom of your Zoom screen, and we'll be asking them to Alan as we go. Alan, the first question there from Dick Tinsley mentioned, should we include a measure of time required to get a day's supply of water? And so in other words, some kind of measure of drudgery required to obtain water that might limit time available for other domestic or economic opportunities. Did you have any comment on that? Did you look at that at all, or was that something that came into the UpGRO work at all?
Yeah, so an excellent question and really good point. Yes, absolutely. The time required to collect water is very much part of the water service delivery of a water point, and most governments are collecting that information as part of the SDGs to make sure that people are able to collect it. So we didn't collect the water ourselves. We didn't collect the information ourselves on time to collect water on each individual water point. We did, as part of the longitudinal study, where we had the community diaries, where we saw how long people were collecting water. But we've done a separate survey in Ethiopia, or two studies there, looking at the length of time for people to collect water and how that changes during drought periods as well. So a hugely important thing to look at.
Thanks, Alan. Thank you for that. And now the second question here gets a little bit further into the point of some of the transdisciplinary or the cross-disciplinary work that UpGRO's done. The question is, can you perhaps go back over the takeaway regarding the 4 criteria that influence functionality and talk a bit about whether they are equally influential or not? And you know, I appreciate this. As you said in the presentation, this is a matter of different solutions for different places. There are, you know, nowhere's the same, but are you able to talk a little bit about you know, you spoke about the hydrogeological issues, the community issues, the engineering and corrosion issues. Could you talk a bit about how those might interact, or whether any of them are more important than the others?
Yeah, sure. So I think that the 4 criteria that's maybe coming up in this question might be to do with the first survey we had, where we looked at how a water committee was functioning. And there really the takeaway was that the only thing that mattered there was whether a community could access and had the money to pay for a repair. That was the only thing, and that was only a small link, but that was the only important thing. The other things, such as how well a community a committee was organized or how it dealt with its finance, didn't seem to be quite as important, although that might be important for other things. I mean, looking at the much bigger survey we did of all the different reasons, yeah, I mean, there's such a myriad of things that are important, but one of them would be the standard of the pumps, so water equipment standards, really. So poor quality rising mains was leading, I think, to quite quick corrosion. It was also to do with water points not being sited in the most permeable aquifers, so aquifers not being great. And then that linked in with the capacity of external support to help maintain that water point when things went wrong. We had a separate piece of work from a PhD student who did some excellent work in the looking at the different types of contracts that were let, and thinking that when turnkey contracts, if you know what they are, where you just pay a lump sum to get something done, had some evidence that turnkey contracts maybe reduce the quality of the water point in the first place. So there's a lot of issues about how water points are commissioned, sited, and maintained. So a lot of things for government to take on. Yeah.
Wow, thanks, Alan. That's absolutely fascinating. How these different issues bleed into each other. That's very hard to keep them separate. So not only did UpGRO look at the different categories of issues, but we've also put them together to understand how they influence each other. Truly, this is I guess what they call a complex problem. It's water point sustainability. There's a few questions here that I'm going to combine together, Alan, on essentially on hydrogeology and sustainability, along the lines of, how do you know that when the water level under the pump is sufficient and will last long enough? And how does that tie into recharge and resilience to climate change and drought? How can you know that, how long the water will last and how it's going to perform in a drought, essentially? Can you talk a bit about that?
Yeah, sure. An excellent question. And that's what a pumping test helps us to get part of that answer. So when a borehole is drilled, in most countries, we should carry out a pumping test, and for a number of hours to see how the water levels fall when you pump out a certain amount of water. And that tells you about the permeability of the rock. So that tells us how quickly the water levels will go down when you start pumping with a hand pump. So any kind of hydrogeologist that you're working with should be able to interpret a pumping test to say how sustainable that water point will be. The second bit then is about recharge, and that's much more difficult to assess. So the recharge, we can sometimes use techniques called chloride mass balance, or different techniques to see what the recharge is. But for a rural hand pump, if you're only taking out a few millimeters of water per year, when you think of rainfall, you're only taking out a tiny fraction. So if the rainfall is fairly high in your area, it's very likely that the recharge will not be a problem. And I've just produced a map of recharge across the whole of Africa that gives you a rough idea of what the recharge is in different areas. So you can look at that and see, is it going to be a problem or not? And if there's a fair bit of rain, then it's probably okay. To assess recharge itself is complex, and maybe the easiest way to do it is just to monitor how water levels vary over the years, to see if are they going down, or are they just going up and down with the seasons.
Right. Thanks, Alan. And it was good, you mentioned earlier in the talk about how for most of the time you did detect active recharge, and at the levels that are currently being abstracted, the sustainability by and large is there even in drought conditions, which is of course an advantage of groundwater. Alan, there were a number of questions coming in about the engineering aspects of these water supply systems that you were looking at, and around dealing with sand falling into the rising main of the pump, around what kinds of materials would you recommend. I suppose the question then to combine it is really, are there technical or engineering recommendations that you would make coming out of this study that make these supplies more robust and resilient to things such as ingress of sand into rising mains?
Yeah, so So there's lots of very good hydrogeological standards out there of how you should construct a water point. And it's good that they are followed. They're not too difficult to implement. I mean, I helped, I wrote a book myself in about 2005 called Developing Groundwater, which is specifically on rural water supply and maybe some of the techniques and standards you use there. I think Richard Carter has just published a book this year as well about rural water supply standards. So there are things you can do to stop sand ingressing. Part of that is just to make sure that your borehole is completely sealed. So you're putting screen at the right place. So open holes without any screen in them can be problematic if you've got an area where there might be sand getting in. So if you put screens in your borehole in a sand area, that should stop sand ingression. If you've got a lot coming in, then it probably means the formation's not being, the borehole's not being constructed properly. So there's techniques you can use, like you put different sizes of sand behind the screens that filter out the silt. So there's different kind of hydrogeological solutions. But if you've got a good hydrogeologist on board in your project, they should be able to just recommend for your site-specific area what's the best construction of a borehole. And that's something we spent a bit of time in this project looking at, is the importance of having that technical expertise on a project, rather than just thinking one size will fit all. Actually having somebody that's able to make sure the project is using the appropriate techniques and methods for the particular area you're in. And some countries have been very good at making sure that a hydrogeologist is assigned to every rural water supply project. In Uganda, for example, they make sure that you have a hydrogeologist as part of any sort of government project. So it's just getting the right expertise. Lots of things that can be done, lots of solutions that can be done.
Thanks, Alan. Thank you very much for that. There's been a few questions coming in on geology and microbial or bacteriological contamination of water points. You mentioned that roughly 20% of your tests showed positive for E. coli, and one of the questions here is on, did you find any kind of link between geology and the prevalence of E. coli or microbiological contamination? Or I guess my own question would be, is that more a function of the construction of the water point? Is there any interesting insights you might have there?
Yeah, thanks. Very, very good questions. And yes, we looked into this and we looked at the geology versus the different water quality constraints of the boreholes. And certainly for the survey that we did of the 600 water points, geology played no role in the amount of coliforms in it. And that's because the kind of geologies we're looking at, it should take several months for the water to get from the land surface down through the rocks to the screen at the bottom of the borehole. So that length of flow path should be long enough for coliforms to die off. So by far the biggest issue is poor construction of water points. Is that even if you've got a nice apron where you've got your hand pump, even if that's connected nicely, if below the ground the top of the borehole isn't cemented in properly, then you can have young water just moving through the soil, the laterite or whatever in the soil, and then hitting the borehole and going down into that's, we believe, is by far the biggest issue with water quality, is this kind of poor construction, which again is good news because it means you can do something about it. We can, by making sure our standards are good and improving the quality of installation, then there should be less contamination from coliforms.
Thanks, Alan. And presumably as well, you mentioned earlier on that the need for monitoring of water levels, and that data is very useful for all kinds of issues on sustainability, but presumably also even basic water quality monitoring and collating that data is your studies show that's very important too, I would imagine.
Absolutely, yeah. Measuring water quality particularly for elements of harm, just making sure we know if you're in an area that's got might have high fluoride or arsenic, making sure that we know what that is. And for just general water quality, the amount of total dissolved solids can be very important. But coliforms, I mean, we all know it's a problem with coliforms because we need to incubate the samples. So, you know, it takes quite a bit of time and effort. So we've been working, and so have others, trying to develop sensors that immediately can tell whether a borehole is likely to be contaminated by coliforms. So some people might have heard of fluorescence. So we're using a tryptophan-like fluorescent probe, and we've published maybe about somewhere between 5 and 10 papers on that. Some colleagues, James Sorensen, Jade Ward, and Dan Lapworth have been leading that work, trying to get this instantaneous screening tool for coliforms. So I think if you're interested in that, then I think read some of that stuff or get in touch, and I can link you up, because I think that shows quite a bit of promise of being a screening tool for potential contamination for coliforms.
Thanks, Alan. Thank you very much. And I'm really sorry. I think we're going to have to call the questions to an end now. We only have 3 or 4 minutes to go. Unfortunately, I could talk about this for another hour at least. Please, I'd encourage anyone to put your questions in the Q&A box. We will get to them. We will answer them all. Alan will answer them all. And we'll be emailing those answers to all the questions out to everybody who attended this webinar. So please, if we didn't get to your question, apologies. But Alan will answer all of them, and we'll be sending that out to everybody. Alan, I'd just like to thank you once more for giving your presentation. It was really, really interesting. I'd encourage everybody to go and look at the UpGRO website, where many of the resources are to be found, including some very interesting links to other resources too, and some of the studies that Alan and colleagues have been doing. As Alan mentioned, it was more than 20 person years of study, this UpGRO project. So it's a substantial piece of work and very interesting for all of us who are involved in WASH in Africa and elsewhere. As we close, we have a minute or two to go. We're going to put another poll up on the screen, which you should be seeing on your screen in front of us. Please take a minute just to fill that in, if you wouldn't mind. It really helps us to understand who's attending the webinars and what your views are and what your interests are. The first question there, in your area, what are the main reasons for the failure of groundwater supplies? And you'll see 5 possible options there. And second of all, did you find the contents of this webinar relevant to your work? And we'd be really grateful if you would fill that in quickly there as we conclude this webinar. Thank you. As I say, please do put your questions in the Q&A box still. We will get to all of them, and Alan will answer them, and we'll get those answers out to all of you. Just to remind you all as well that a copy of the presentation and a recording of the presentation, both in English and in French, will be available on the FSN Network website for download. So if you've missed this or missed any part of it, or know people who would like to see it, please don't hesitate to download those resources and share them as you like. I'd also like to remind you, this is the first in our second series of O&M webinars. On September the 21st, we have a speaker on the Uptime Global Consortium talking about some of the solutions that they've developed to long-term issues of water point functionality, particularly in Africa. So please tune into that one, September 21st. The registration's on the FSN Network site, and it would be really great to see you there as well. Just in the minute we have remaining, the poll results. We're seeing, unsurprisingly, thanks to Alan's very clear explanations, most people say there is no simple answer to borehole, to engineering failures. It's normally a complex mixture of things. A substantial minority also point out that financial and cost recovery is a major issue too. And when it comes to, did you find the content of this webinar relevant to your work? 2/3 said very likely and a third likely, and I'm very happy to say only nobody at all said unlikely. So Alan, thank you once again for what has been a really interesting presentation. I hope that the audience got as much out of this as I did. We will see everybody with a bit of luck on September 21st for the next one of our O&M series of webinars. Thank you all very much for joining us. We really appreciate it, and have a great rest of your day. Alan, thank you once again. And last of all, let me thank our very capable interpreter, Daniel, who's done a fantastic job today. Daniel, thank you so much for your sterling job in the background. Thank you all, and we'll see you next time. Bye-bye.